All right, so 4.2, least squares regression. Our least squares regression line is the line that minimizes the sum of the squared errors or residuals. All right. It's also the line that best explains the relationship of the data. And that's just a generic representation of what your least squares regression line would do for you. Like I said, it's the sum that is the line that best sums up the data. All right. All right, gonna scroll up. All right, finding the regression line. We have an equation for that, in which we'll be able to use this equation to predict data or predict outcomes. We use this information, previous observed information to predict outcomes. So this character right here is called y hat. Whenever you have that, I guess you would say triangle without the base on top of it. This symbol over here is the hat symbol. So it's considered y hat. And that is our predicted y. That'll give us our predicted value. So this y hat equal to b1 x plus b0 or b sub 0. So b1 is going to be calculated by r, which is our correlation coefficient, times s sub y over s sub x. And we'll see what those mean in a second. B naught or B0 is going to be y bar minus B1 times x bar. So notice you do have to find B1 first in order to find B0, because B1 is right here in the equation of B0. Also take note that B1 is our slope and B0 is our y-intercept. So that's something that I'm pretty sure my math lab asked. So those symbols in the calculations are right there. Talked about R last class, which is the correlation coefficient. X bar is the mean of your X values. S sub X is the standard deviation of the X values. Y bar is the mean of your Y values, and S sub Y, is the standard deviation of your Y values. All right, scrolling up. All right, so this regression equation, I already mentioned this, but it's written right here in the purple. The regression is used to predict an observation based on previous observations. All right. So there's two different ways they could ask you to find a regression line. First way is if they give you, let's go back to the formula. If they give you all of these pieces, and then you just plug them into the formula and find B1, then find B0. And that's the first example. The second way is to give you a list of data values. And then in that case, it would be best that you plug it into some type of app, website, or calculator, like I mentioned to you before, to find what the regression line would be. So once again, the first example we're about to do, they're going to give us these pieces. We'll just plug them into the formula and calculate. And then in the second example, they're going to give us data values, just the data values in its rawest form. In that case, you would type it into, a website or app, and then get your regression line. So final regression line, they give us R is negative 0.946, X bar is 4, S sub X is 2.44949, Y bar is equal to 10, and S sub Y is equal to 5.612486. All right, so our first step is to find B1. So we would take, notice what we need is R, S sub Y, and S sub X. And that's what we get right here, R, S sub Y, and S sub X. And we plug them into the formula. This is R, this is S sub Y, this is S sub X. And put that in the calculator, you should get negative 2.1676. And always make sure you pay attention to my math lab and how many data values they ask you to go out. Or not data values, decimals they ask you to go out. So I went 4. But if they ask you for B1, they ask you to go 5 or just do 3, you make sure you pay attention to that. So B0, now we're going to take Y bar, X bar, and our B1 that we just calculated and plug it into the formula. So it's 10 minus negative 2.1676 times 4. We should get 18.6704. Any questions? right, so if we put B1 and B0 into the formula, or into the equation, the equation is right here. Y bar is equal to B1x plus B0. And that's going to be Y bar equal to negative 2.1676x plus 18.6704. And so here, someone had asked me about how my math lab wanted it. So my math lab will set you up this way. They'll give you boxes to plug in and make sure you plug in properly. Notice B1 is what's sitting in front of X, or is what is attached to X, whichever way you want to look at it. And then here, I just emphasize that, this is the same thing as this. Just that, the 18.6704 is first. So as long as your 2.1676 is negative, whether you put it in front or back, it's still the same thing. All right, questions on that one? This one didn't ask us to use it, so we'd use it in the next example. The application of it, but this just showed us or taught to us, gave us a reason to find it. Just told us to find it. All right. So the next one, telling us to find a regression line. Predict the distance the ball will travel when hit with a club head speed of 103 miles per hour, and determine the residual for the predicted from the result in C. Is the distance in the table above or below average among balls hit at 103 miles per hour? Okay, so I'll give you guys a chance to copy that first. Write this better. All right. You good to scroll up? All right, so here is that. This is the same data values or data sets that we had from before, dealing with the club head speed and the distance that the ball travels. And before, remember, we found the correlation coefficient between the two data sets, but this time we will find the regression line. So like I said, it's the same data set. Let's do this. So I would just type in regression line, easy calculation. First one right here. All right, so just like before, we just type in the data values and hit calculate. And I didn't even check to make sure I'm still straight, 57, 64. Okay, so that's our regression line down at the bottom. Any questions on that? So if they give you a data set, the easiest way to do it is to just, mentioned before, have an app, website, or calculator that can calculate this thing for you, so that all you would have to do is apply it. I remember we talked about before which one was X, which one was Y, which one was our explanatory variable versus our response variable. So over here was our explanatory variable that explained why the ball would travel the distance that it did. This is our response variable. It responds the distance, the ball travels responds to how hard or how fast the club head was moving. So this is what we saw in easycalculation.com. All right, problem with A before we go to B. All right. So B said predict the distance the ball will travel when hit with a club head speed of 103 miles per hour. So that means X is going to be 103. Plug 103 into the equation for X. So it's 3.166 times 103 minus 55.797. And that is 270.3 yards. So that's the prediction. All right, any problems with B? All right, then C says determine the residual for the predicted value from the result in C is the distance in the table above or below average among balls hit at 103 miles per hour. So residual, or in other words, error. Remember back in our initial definition, error and residual mean the same thing. You take your observed y and subtract the predicted y from it. So we have an observed 103 miles per hour in its result, which is right here. So when the person actually hit it at 103 miles per hour, it went 274 yards. So we take the observed, which is 274 yards. Also, your observed is just y. Observed is just y, wherein your predicted is y hat. So you take your your observed, which is 274, and subtract the 270.3. And down here, all I was saying is I got this one from the chart and got this one from the equation. So, in other ways you can distinguish between the two. And I got 3.7 yards. And the conclusion is the observation in the chart is above average balls hit at 103 miles per hour. And it's above or considered above average because it is positive. So if it was negative, then you would say it was below average balls hit at 103 miles per hour. Questions? All right, any problems before we look at 4.3? All right, so one last thing, your coefficient of determination. It measures the proportion of total variation in the response variable that is explained by the regression line. It basically tells us how reliable the regression line is. It's also the correlation coefficient squared. All right. It's denoted by a capital R squared, and it is between 0 and 1 inclusive. If R squared is 0, the regression line has no explanatory value. R squared is equal to 1, the regression line explains 100% of the variation in the response variable. All right, before we go to the example, any questions? All right, so determine and interpret the coefficient of determination for the club head speed versus the distance. All right, so our first step is to find the correlation coefficient. We did that last example. Nope, that was last class. We did that. But we found R to be 0.939. So let's find the square of the coefficient of determination. No, find the coefficient of determination. And the first thing we'll do is square R in order to do so. So we take our 0.939 and square it. And so here's the notation for the coefficient of determination. And really, all that means is that you're going to square the lowercase r. We know lowercase r is correlation coefficient. And that gives us 0.882. Or if they were to ask for the percentage, you move the decimal 2 places to the right. It's 88.2%. All right, so an interpretation of this number, 88.2% of the data, of the variation in this distance is explained by the regression line. Subtract that from 100, that means 11.8% of the variation is explained by other factors. So in other words, if you were to make a prediction using the regression line and it's not accurate or is not close to being accurate, then there are other things that are in play. There's 11% chance that other things would be in play in order to distort what you actually experience in comparison to the prediction. You know, whether it be the wind, I mean, because you're outside, you know, you never know what could happen. The wind, I don't know, a bird, you may hit a bird, I don't know, something, you know, you talk about hitting a golf ball, so different things in the atmosphere that could occur that can alter the distance. If when the ball rolls, if that's part of your distance calculation, if the ball, you know, lands on a slope and it rolls down. So that last statement is what it basically boils down to, is that the regression line has an 88.2% reliability. Which means 88.2% of the time it will be accurate. All right. Questions? Any questions? I think that's it. Yeah, that's just something I was talking to somebody else about. All right, scrolling up. This is nothing right. Yep. All right. So now you are equipped to do assignment 2. Remember we had assignment 1. That was 4 problems. There was 1 problem out of each section. Assignment 2 is going to be 3 problems out of each section. 1 problem out of each section, which will be 3, and it's based on chapter 4, and that's right under assignment 1. So make sure you check that out and get that to me as soon as possible. If you haven't done assignment 1 yet, make sure you get that to me as well, because you don't want zeros for no reason, just odd problems that you guys need to make attempts at. Make sure you're good with the concepts. See if you have any issues before we continue to go any further. Next class we'll be reviewing, and the way I do my reviews is pretty much I come to class and see if you guys have questions. If you ask me to do something or do a problem like something else, that would be the time. If you want to see another type of problem done, that would be the time to ask. And yeah, go like that. Or like I said, if you have a question that you come across and you want to see it done, or you just don't know how to get the answer, or just need help in which direction to go, next class will be the time to bring that to the table. All right. Any questions? Questions, concerns, or comments? Everybody good? Everybody straight? All right. Well, that's all I have for today. That's it for chapter 4. So, chapter 4 was on 3 sections. See somebody in the chat. And oh, I was about to say what? Somebody had sent a message privately, y'all. So she misspelled. I mean, it was misspelled. So yes, you can find it in the e-text. All of this you can find in the e-text. Yep. Questions? Everybody good before we close out? All right. So that's it for today. You guys have a great day, and I will see you on Thursday. All right. Have a great one.